Today we will be verifying whether or not two functions are inverses. So note that in order for us to verify two functions are inverses, I have to have f of g of x equal x and g of f of x equal x. If both those statements are true, then we can say that the two functions are inverse. And how we know inverse is this f to the negative 1 power. It's read as f inverse. So this means if they are inverses, then f inverse of f is equal to x, and f of f inverse of x is equal to x. So it's the same thing, except instead of saying an f inverse of x or f negative 1 power x, we have f of g. So what we're going to be doing is verifying whether or not two functions are inverses. So it's just two steps that you will have to do. The first thing you'll do is you'll show that f of g of x equals x. Okay, so what we'll do, because f comes first, we'll write the f function with empty parentheses, and we will insert the g function in its place. And then we just simplify. We know the 3's will cancel, so x minus 2 plus 2, and then the 2's cancel, so we have x. The second thing we'll do is we will find g of f of x. Right, this is what we wanted. So this time we'll start with the g function and put empty parentheses where x was, and we will insert the f function in the empty parentheses. So the 3x plus 2 goes here, and we just simplify from there. So we know in the numerator the 2's cancel, so 3x over 3, and then 3x divided by 3 is just x. So because we had our f of g of x equaled x and our g of f of x equals x, we can say yes, they are inverses. I want you to take a minute or two and try this example you tried. Okay, so hopefully you found that f of g of x equaled x and g of f of x also equaled x. Okay, so we're just going to verify whether or not the two functions are inverses again. So we're just going to do the exact same thing. So the first thing we'll do is f of g of x. So notice that we will take our f function and we'll put empty parentheses where the x was, and we will insert g in place of the empty parentheses. And then note that when you combine like terms under the radical, you just have the square root of x squared, which we know to just be x. So that one is good. Now the second thing we'll do is we'll find g of f of x. Okay, so we'll start with the g function, put empty parentheses where the x is. Now this x is greater than or equal to negative 4. It just states the domain, because remember, if you put a number smaller than negative 4 and for the f function for x, you have the square root of a negative number, which is complex. Okay, so we'll just put in the x squared minus 4 here. And it, oh, wait. That was not wise. Remember, we're putting f in place of g, so I have to instead put f of x down here. Okay, so the square root of x plus 4. Now, remember, when you square a square root, they undo each other, so we'll have x plus 4 minus 4, which is just equal to x. And so because we had g of f of x equal x and f of g of x equal x, we can say yes, they are inverses. Okay, so what I want you to do now is try the example you tried. And like the previous example, notice that f of g of x equals x and g of f of x equals x. So we can say they are inverses. Okay, last type of problem. We're just doing more of the exact same process. So again, we will find f of g of x first. So we're going to write our f function and put empty parentheses where the x would be, and we're going to insert all of g in its place. So g is the square root of x plus 4. And when you combine like terms in the parentheses, in the, the original parentheses, the 4's cancel out. So we actually have the square root of x quantity squared, which we know is just x. And remember, the second thing we'll do is we'll do g of f of x next. So this time we'll write the g function, right, and we'll leave the x spot empty. And what we'll do is we'll put all of f in underneath that radical. Remember, when you square root a square, it just undoes itself. So we'll have x minus 4 plus 4, which is just x. And again, because we had f of g of x equal x, and we had g of f of x equal x, we can say they are inverses. Okay, so next thing I want you to do is to try this last example you tried. And hopefully that you did find that f of g of x did equal x and g of f of x are x, so we can say they're inverses. And that's all you have to know for verifying.